this optimization problem, we're finding the rectangle of largest area that can be drawn under a parabola. The first step in solving this problem is to read through the problem carefully and figure out what information we've been given and what we're asked to find. The first step in solving this problem is to read through the problem carefully and figure out what information we've been given and what we're asked to find. We want to find the dimensions of the rectangle of largest area that has its base on the x-axis and its other two vertices above the x-axis and line on the parabola y is equal to 8 minus x squared. Step 2 in solving this problem is to fill in the 4 categories that I've listed here using the information from our problem. I went ahead and drew a rectangle that has its base on the x-axis and its other two vertices above the x-axis and line on the parabola. What we want to do now is to put variables on our picture, and our variables need to relate to what we want to find. We want to find the dimensions of the rectangle with the largest area. The rectangle is written here in red, so that's what we want to put our variables on. I'm going to label this piece as x, and this piece as y, and then this piece as x again. Notice that we didn't label the entire base x, we broke it up into 2 pieces. And the reason that we did that is the point xy is this point right here, and it lies on the parabola. And if we let x be the entire base, we couldn't identify that point as xy. Notice that x can be as big as this point right here, so I think we should go ahead and label that point. That point is where our parabola, 8 minus x squared, is equal to 0. So that point is x squared is equal to 8, which gives us x is equal to the square root of 8, or 2 square root of 2. Let's now label our variables. 2x is the width of our rectangle, and then y is the height. You always want to label the variables. Now let's write down the equation that relates these variables. That equation was actually already given to us, and that is the equation y is equal to 8 minus x squared. Now let's look up at the problem again and see what we want to maximize or minimize. We want to find the dimensions of the rectangle of largest area. So that means we want to maximize the area of the rectangle. So let's write down the formula for that area. A is equal to the length, which is 2x, times the height, which is y. So our area is 2xy. Now what we want to do is put our area in terms of just one variable. So we're going to let this y equal that y. This gives us A is equal to 2x times 8 minus x squared. In order to maximize our area, we are going to have to take the derivative of A. So what's really good to do is to go ahead and rewrite A in the easiest way that we can take the derivative. I'm going to write A as 2 times 8, which is 16, so 16x minus 2x cubed. And let's highlight that because that's the area that we're going to take the derivative of in a few minutes. The last thing we need to fill in is the domain. X can range from 0 all the way up to 2 root 2. So we're going to write this as 0 is less than or equal to x is less than or equal to 2 root 2. And this is a closed domain, so I'm just going to write down closed. That is going to matter to us in just a few minutes. Our third step is to take the derivative of our area function, set it equal to 0, and find the critical values. I'm going to rewrite A. A is 16x minus 2x cubed. Our derivative, A prime, is 16 minus 2 times 3 is 6x squared. And we are going to set that equal to 0 and solve for x. This gives us x squared is equal to 16 divided by 6. Now we're going to take the square root. So x is the square root of 16 divided by 6. So we can say that x is equal to 4 divided by the square root of 6. Let's go ahead and let's highlight this. And then notice that our base is equal to 2x. So I'm just going to make a note over here that 2x is equal to 8 divided by square root of 6. Let's now find what y is equal to. Y, if we go back and look up top, is 8 minus x squared. So this is equal to 8 minus 16 over 6. This is 48 minus 16, all divided by 6. And that is 32 divided by 6. So we can say that y is equal to 16 divided by 3. What we want to do now is find what our area is equal to. Our area, going back up to the top, is 2xy. We could have used the formula for area that I just wrote down by step 3, but that one's actually harder. So let's use the formulation 2xy, and let's plug in x and y. So our area is 2 times x, which is 4 divided by root 6, and then y is 16 divided by 3. This is equal to 128, all divided by 3 times root 6. And let's go ahead and let's highlight that answer. Now, it may feel that we're done, but we're not. What we have to do now in step 4 is we need to justify that this answer that we just got is a maximum. Since our domain up here is a closed interval, the way we have to justify this is compare the value of our area at our endpoints to that of our critical point and just see if the one at the critical point is our biggest one. A at 0 is equal to 2xy when x is 0. So this is just equal to 0. And then a at 2 root 2 is equal to 2 times 2 root 2. And then let's go back up here. At this point right here, y is 0. So we can plug in 0 for y. And we get 0. And then we have a at our critical point, which was 4 over root 6. And we found that that value was 128, all divided by 3 root 6. And that is bigger than 0, so that is our maximum. Now, our last step is to reread our problem and then clearly state our answer in a complete sentence. Let's go back up to the top and look at our problem. We are asked to find the dimensions of the rectangle. So that's what we need to put in our answer. We can say that the width of the rectangle is 4 divided by root 6, and the height is 16 divided by 3. And there's our final answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.